Hey folks, this is Joel and I'm back with another video on VPNs. In the earlier videos, I think we already saw what a GetVPN was. We also saw VRFs, right? We talked about VRFs. Then we went ahead and we talked about VRF-aware VPNs, right? So where VRFs and VPNs existed together in a network, right? And in this particular video, we are going to look at a combination of VRFs, everything what we have learned till now, right? VRFs, VPNs, and GetVPN. So that's why the video is titled VRF aware GetVPN. So we will be running GetVPN in a network which has VRFs, right? So we'll be borrowing all the concepts what we have studied till now. So this is kind of like the finale of all the last 3-4 videos which we put together, right? So the network what you see here is pretty simple. So I have like two VRFs in this network. One is, you can look at the colors, right? So we have one VRF which is which includes the router R1, and the VRF resides obviously on my router R2, right, where this is the place where we'll be defining both the VRFs, so the router R2 will be present in both my VRFs, right? So these are going to be my two VRFs, and we have a router R4 and R5 over here. These routers are not going to be part of the VRF. They will have all their routes in the global routing table, whereas yeah, these two routers will be part of the VRF, and this is the place where we'll be defining both the VRFs. Now the main final objective is to kind of like create a get VPN scenario, right? To have a get VPN, wherein so the final scenario would be R5 will act like a key server. As you recollect, in case of my get VPN, we have something called as a key server and the group members. So in this case, R5 will be my key server, and R1 will be basically creating two VPNs, right? Because these two are separate networks, right? We don't want because they are separate VRFs, right? It could be in a real production scenario, it could be like complete different companies, right? So we'll be creating two different VRFs, VPNs, my bad. So we will have one get VPN which is catering to my this particular VRF, and then we'll have another get VPN which will be catering to this particular VRF. So when I say two get VPNs, obviously there will be two sets of groups, right? GDOI groups, and obviously two sets of group members, right? So that's the background. Let's start configuring. So the first step is let's go and do some configurations of the IP and set up the VRFs, right? Let's do that. Yeah, so let's start with router R1, right? So I'm on my R1, right? So when you go to R1, what I'm going to do is I'm going to start with my loopback address on my R1, which is 10.11.1.255, right? So I'm going to use that as my loopback address, and I'm also going to use my Ethernet address. I need to put in an Ethernet address, and the address is basically the network is 10.10.10 network, so I'm going to use that. I'm going to use .1 for this particular interface here, and I'm going to use a static route, right? I'm not going to use any kind of routing throughout this access. I'm going to play around only with static routes. So as you see, there's a static route here which is coming on my R1, right? And the static route is towards my 10.10.10.2, which will be this interface, right? Just to recollect, I'm not going to put a VRF, I'm not going to define a VRF on my R1, right? I'm going to do the VRF configuration on my R2, because this is the router where we want it to be divided into two, right? So that's why, and that's how it looks, right? So this is how it looks. Let's put in this config. There you go, we have done that for R1. Let's do the R3 as well, right? Because it's almost the same, the configuration will look almost the same. Let's do that. So there you go, let's do it for R3. Okay, so in R3 we start again with the loopback interface, which is 10.1.1, because you might think that I'm using the same address again, but mind you that we are using VRF, so this is going to be using a separate routing table, and this will be using a separate routing table, so it doesn't matter. I'll be using a 10.1.1 as loopback, and my Ethernet address over here would be 10.20.20.3, right? I'm going to use that again. I could have used 10.10 as well, but I'm using this because for my VPN scenario I would require it to be a different address. But if it was simple VRFs, right, I could have still used the same network. I could have used 10.10.10 and it would have worked. But to cater to my later needs, I'm using a different network over here. So that's my 20.3 over here, and I'm also using a static route where I will be trying to reach to my 10.2.2 network, which is on my router R2, right? So this is the network, and I'll be reaching this network through through R2 again, which is the next stop, right? 10.10.2. So this is going to be 10.10.2. So I'm going to drop that. There we go. Now let's do the configuration on my R2, which seems to be the important part here. And because it's R2, we'll have to do my VRF configurations, right? So let's do that. Let's pull that up. There we go. I got the configs. Let's go to R2. There we go. So this is going to be my configs on R2. So I first define my two VRFs. One is customer A and customer B. I call the red customer over here as customer A, and the one in the bottom is the customer B, right? Following that, what we do is the Ethernet 0/0 interface. On this interface, I define the VRF forwarding, right? I have to define, because I have defined my VRFs. Now I have to put my interfaces in a particular VRF. So this interface is towards R1, so that's why it's going to be in customer A, and my IP address will be 10.10.10.2, right? Because this is the network. And I also define loopback address, and you have to look carefully. I'm also defining the VRF for the loopback address, because I want everything to be connected in the VRF, right? So it's going to be 10.2.2.2 over here. And the next part is, again, I'm going to use a static route, right? I'm going to use a static route saying that because I'm not using routing, that's why I'm doing with starting routes over here, right? So I'm telling this router that if you have any packet, so if it was a normal static route, I would have not mentioned these two parameters, but because it is inside a VRF, this is how you define a static route for a VRF, right? So we write IP route, we define VRF customer A, because it is customer A, and then we say that in order to reach the 10.1.1 network inside my customer A, right? So in order to reach this particular network, you need to go here. So that's how I got this. So this is 10.10.1, which is this interface, and so that's my static route, right? Also, that was just on the customer A side. I need to replicate the same thing on the customer B as well on the bottom. So I have this interface 0/1. I put in my VRF under that. Then I have my loopback address. Again, I put in the VRF, and then I do the same static route where I tell, hey, you want to reach a network which is part of customer B, then please go to this particular address, which is 10.20.20.3, right? So that's done. So I have done all the IP connectivity over here, right? Let's probably go and finish the stuff on R4 and R5. Let's do that. Yeah, so when you go towards R4 and R5, there is still one interface over here, serial interface 2/0 on R2, which which we haven't done. So just to remind that all these interfaces are not part of the VRF. These are going to be part of the default routing table, right? Yeah, okay, before doing this, let's just check what we have done. We have actually set up the VRFs on R2, and basically this network should be reachable within itself, and this network should be reachable as well. So to test, let's go to R1 and see if we can ping the other side, which is 10.2.2.2. There you go, it's working, right? Let's see if we can do the same thing on this as well on R3. Okay. mm, I think that did not work. We need to check that. Okay, so I think that's a mistake. You see the static route here, what I have defined, it has to be 10.20.20. So let me quickly change that, right? Let's do that. There you go. Let me reapply the right one. So this was supposed to be 20, right? I put in a 10. So there you go. That's good. Now I think this should work. Yeah, now it's working, right? So we have the connectivity from R3 to here. We could check here as well. We could do a ping to VRF customer A 10.1.1.1. That works. Let's see if customer B works. Yeah, that works as well, right? So that was pretty much the VRF configuration, right? Let me just correct this part here, 20. Okay, so the next part what we gotta do is we have to do the configuration of this part of the network. So let's start with configuring the serial interface on my R2. Just to remind, this part of the network will not be part of the VRF, right? So let me just clear the screen because it looks little, yeah. So let's go to R2 and let's do the configuration now for the serial interface, right? So this is going to be my serial interface, which is 2/0, and I'm going to put an address 10.24.24.2, right, because that is the network here. There you go. I am dropping that. Okay. I'm also going to put uh, a default gateway, or basically a static route, right? I'm going to put a static route which would be IP route 0.0.0, and I'm going to point it towards 10.24.4, which is going to be this one, right? So it's just a static route which says that, hey, any packet which comes here has to go down to the the next stop, which is going to be my R4 here, right? So there you go. We have set this IP up, and also we have set up a static route to R4. Now let's do the connectivity on R4, right? Let's do the connectivity on R4. Okay. So on R4 we have two interfaces to be configured. Let's go down there. There you go. We have serial interface 2/0 towards R2, and I'm basically putting 24.24.4, and the other interface, because this network is 10.45.45.0, I'm going to use this particular address for this network, right? So there you go. I'm done with R4 as well. The only thing which is remaining now is R5, and then we should have like a connectivity from here to here, right? So let's see that. There you go. So on R5 what I'm going to do is, this is going to be interface 2/1. So on that interface I have 45.45.5, this interface, and I also will put a static route saying that, hey, you get any packets, push it over here, right? I'm doing that just so that, you know, all these three routers are like connected, right? So there you go, that is done. Just to check, let's see if we can ping my R2, right? So that's going to be 10.24.24.2. there you go, it works, right? So this connectivity is also established. Wonderful. What do we do next? Now we have to set up the GetVPN, right? So what we have done now is we have broken this router into two, so that we have like VRFs, and we have like set up VRFs over here. We have set up a VRF over here. We have like a customer A and customer B over here. We also have like a network here which is connected, which means R5 is connected to R2. They are reachable. Now what we got to do is we need to have a VPN setup, right? Because without VPN the data will not be encrypted. So whatever the data is getting transmitted inside my VRF over here or over here, it should still be encrypted, right? So to do that, let's use GetVPN, because, you know, in GetVPN we have this mechanism where we can like create a key server, and then rest of the nodes can download all the VPN configuration from the key server, right? So in my case I'm going to use my R5 to be my key server, and we'll have two VPNs. One is customer A VPN, other one will be customer B GetVPN. These two will be the group members for customer A, and these two will be the group members for customer B, right? Now So to do that, I think you would have read this before. The prerequisite for a get VPN is that you need to have a completely routable network, which means every single router over here should be able to reach my key server, which is my R5, right? Because R5 is the key server, and that's the place where you store all your configurations. That's the place where you control the entire VPN, and as a result, all the routers you should be able to reach to R5. Now let's trace a packet. Let's trace a packet from R1 to R5, right? So let's say R1 has to reach to R5, right? So what happens? R1 doesn't understand the IP address of R5, which is 10.45.45 network, right? It doesn't understand because this is present in the global routing table, and this particular route is not advertised, or R1 basically has no idea about what is 10.45, right? So we inject a route on R1 saying that, hey, if you have a packet for 10.45.45.5, right, what you have to do is send that packet to the next hop, which is my R2, which is 10.10.2 over here, dot 2, right? So we got to do that. Okay, so yeah, let's do this step by step, that way it's easier. So let's do that, right? So let's do that on R1. Let's go down to R1. Yeah, there you go. So this is what I'm telling. IP route 10.45.45.5 255 255, which is basically my R5, right, which is my key server. Now to reach your key server, the next hop has to be 10.10.10.2, which is my R2 over here, right? Let's drop that. So we have added this route manually onto my R1 server, R1 router, right? Now we have to do something called as route leaking, because the packet has now arrived at R2, right? And yet we have not reached our destination. Our destination is reaching R5. We are tracing the packet from R1 to R5, right? So we need to, how do you leak a route from a VRF to the global routing table? Because if you remember, this network, all of this is part of the global routing table. They are not inside the VRFs, and you see that there is a interface here 2/0, right? And the 2/0 network over here is present as part of the global routing table, right? So if a packet arrives over here with 10.45.45 inside my VRF, my VRF will not know what to do with that packet, because the VRF routing table doesn't have that, right? So if you look at my let's show you, do show IP route VRF customer A, right? There you go. So I don't have any network which says 10.45.45, right? So VRF doesn't know that. So now we need to inject a route inside this, so that the VRF knows how to reach to this particular R5, right? Because the packet has arrived here. So we do that. We need to do that on R2. Let's do that. Yeah. So this is what we do. Okay. Give me a minute. Yeah. So this is what we do, right? So um, I put in a route on my VRF. So this is the syntax which you need to follow when you're leaking a route from a VRF to a global routing table. So you're telling, hey, this is the route VRF customer A, right? This is what you're doing inside the VRF, and this is where you have to reach. You have to reach this particular destination, and what will be your outgoing interface, which will be serial interface 2/0 over here, and what is going to be my next hop, right? Whenever a packet of this particular destination comes, my next hop has to be 10.24.24.4, which is part of the global routing table, right? My global routing table basically knows this particular address, which is 10.24.4. So it is kind of like connecting my VRF and my global routing table, right? So I have a packet which is in my which is referencing my VRF routing table, and the VRF routing table basically doesn't know what is 10.45. So I kind of inject a route, so that I indirectly tell my VRF routing table for customer A that if you see a packet for 10.45 or 45, then you need to send it to this particular next hop, right? So this is basically called as route leaking, right? So that's what we are doing here. So we do that. Now just to check, you can see, let's run the same command which we ran earlier. There you go. Earlier we did not have 10.45 in the network for I mean in the routing table, in the VRF routing table for customer A, but now you see we have 10.45 over here, right, for customer A. So we were successful in doing that. So the packet has now reached R4, and R4 basically knows how to reach R5, so it's all good, right? So the packet is able to go this way. Now let's also trace the reverse order. A packet comes from R4, R5, and it basically wants to reach my 10.10 network, right? So how would I do it? R5 has a default route, so it would, whatever packet comes, it would directly push it to R4. Now I need to do something on R4. I need to tell where this packet has to be pushed, right, on R4. So let me do that. Okay, let's do that. There you go. So I'm explicitly telling that if you get a packet for this network, which is 10.10.10, which is my VRF for customer A over here, what you got to do is you need to send it to the next hop, which is going to be my R2. So this is going to be my R2, right? So I do that on my R4. So the packet has reached here. Now what we are doing is we are doing the opposite, right? The packet has reached my routing table, my global routing table, right? And now it has to actually switch, or it has to go to my VRF, right? So a packet has to go from a global routing table, it has to go to my VRF, right? So it is exactly opposite of what we did earlier. So how do we do this? That's pretty again simple. You need to tell the packet on which interface it has to go, right? So that's what you are supposed to do. So we'll do that now, right? So this is what we'll be doing on R2. Give me a minute. Let's clean this up because it looks really congested here. Okay, so okay, maybe not this one. Cancel. Yeah, so this is what I have to do. It's not getting copied, my bad, sorry. Okay, my bad, it's not getting copied. Let's try this. IP route, right? What we are trying to do now is we are trying to inject a route from the global routing table inside my VRF, right? So I'm telling how do you reach to this network, 255.0. So it's pretty simple. You just need to mention the interface of the VRF. In this case, the interface of the VRF is Ethernet 0/0. So there you go, that's it. So now whenever R2 receives a packet on this interface for 10.10.10, though it doesn't know this network, what it will do is it will send it on this interface, right? So we could look at the routing table, how it looks now, right? So here you have, it clearly tells that for this network just push it on this interface Ethernet 0/0, right? So now once the packet is sent here, then it knows how to reach to my VRF, right? So that's what we did for customer A. Now we need to do the same thing for customer B as well, right? Let's do. So what we did first, we'll have to do the changes on R3, right? Let's do that. It's basically the same what we did earlier, but we are doing it on this one, right? So this is going to be my first step where I'm defining a route to reach my R5, and I'm telling any packet which has to go to that R5, it will have to reach my R2 first. So that's what I do here. Once that is done, once the packet has reached R2, I need to do the changes on R2 basically, which would be, right, this is basically the route leaking which we did earlier. Cancel, my bad. me a minute. Yeah, so this is going to be my route leaking, where I tell my R2 router that there is when you get a packet inside this VRF and it wants to reach to this 1045.45, right, then it has to actually push this particular packet to my R4, right, along this interface, which is serial interface. So I do that. So the packet has now successfully come to R4, and from there it will go to R5. Now when you do a reverse tracking, the packet first starts from R5, it comes to R4 because there is a default gateway here, but R4 doesn't know this internal address, so we need to configure that on R4. Let's do that. So let's go down to R4. There you go. So I'm explicitly telling, hey, you want to reach this 10.20 network, which is this one, then you need to first go to 10.24.24.2, which is my R2, right? We are done. Now the packet has come to R2. We have to inject this route from the external or the global routing table inside my VRF table, right? So let's do that. Let's do it. Yeah. So I'm injecting, I'm telling if you want to reach this 10.20 network, then you have to go out, or you have to go to this interface, which is 0/1. So that's what we did earlier as well for customer A, right? So now we have done all of that, right? We have completely established the connectivity. We can check, which means I from R1 I should be able to ping my R5, which is 10.45.45.5. Yeah, that works. Let's try the same thing on R3 as well. Is it able to reach? Okay, my bad. R3 is not able to reach. Okay, is there an issue? Let's see what's the issue. Okay, let's see that again. Let's see what's happening with R3. Give me a minute. Let me see this. Hey, so I figured out what the mistake could be. So if you go and see the routing on my R2, let's see that. So you see that on my R2 we missed the last step, right? So we have told R2 the global routing table of R2. We have told the we have mentioned this route where we are telling, hey, you get a packet for customer A, then please exit it or please throw it to this interface, which is Ethernet 0/0. But we have not done the same thing for my customer B, right? So let's do that. So that's one configuration which is left on R2, right? So let's quickly get that done. There you go. So we are telling you get any packet for 10.20 network, then you gotta send it on Ethernet 0/1, right? There you go. So I think now we will be able to reach from R3 to R5, right? Let's check that. Oh, sorry, my bad. It's supposed to be 10.45.45.5, not 56. Yeah, that works. So we have like connectivity from R1 to R5 and R3 to R5. So now I think we are all good. We have we are done with the prerequisite for GetVPN, which is basically a completely routable network. So now let's just go and do the GetVPN configuration, right? So let's start with the key server, which is going to be my R5. Let's go down to R5, right? So let's pull that up. That's going to be a nice configuration. Let's look into that, right? So on R5, we're gonna drop this. So we'll start with the key. It's a key server, so we need to start with the phase 1 configuration, which is we have seen all this while. ISACM policy, we're gonna drop the pre-share, authentication, MD5 hash, 3 days encryption. Group 2 is basically for again phase 1 because we'll be using the Diffie-Hellman keys. The next thing is we need to define the pre-shared keys, right? So that that's why we are going to use the since we have two networks here, right? And this is going to be my common key server for both my VPN. So I'm going to use two different ACLs here. One is going to be my 10 network, which is my VRF-A and or the customer A, and the other one is my 10.20, which is going to be a customer B, right over here. So that's done. Then we do phase 2. Again, we have two different phase 2 configurations, which is one is the only difference being I think customer A uses MD5 and customer B uses SHA, right? So yeah, we have done that. Now we need to do the IPsec profile configuration, right? The profile has to be defined. We are defining two profiles for two separate customers, right? We are done with that as well over here. So you can see the profile definition, and we are also using the set transform set command to attach the phase 2 configuration whatever we did to the profile, right? The next is we need to define the interesting traffic, right? This is very important. So the interesting traffic basically in my VRF1 would be basically any traffic which goes in the 10 network, right? So that's why I have used this kind of a wildcard. So I'm basically telling any traffic which is starting from 10.0 network and going to the 10.0 network has to be encrypted, right? So any communication happening between 10.1 to 10.2, vice versa, either it is starting from here and going here or from here to here, right? All of that traffic will be encrypted. And I'm repeating, basically creating another ACL. It's not required, you can use the same ACL as well, but I'm just creating it twice because we are talking about two different VPNs here with the same values, since my network below has the same wildcard, right? So the same values what I used here are applicable here as well, because um, even this is nothing but a 10 network, right? Since it is a get VPN, we are going to use the GDOI configuration, right? We need to do that. GDOI group has to be defined. We are going to use two different groups because we have two different VPNs. This is compulsory, mandatory, because identity number is something which defines the get VPNs, right? So we are going to use identity number of 100 for the top one and identity number of 200 for the bottom one, right? The rest is very much the same what we did earlier in the get VPN. So when we are going to define server local, which is going to be my key server, then we go ahead and put the IPsec configuration. So we put in the profile, right? We attach the profile to this group which we defined earlier over here, and the match address. So I'm going to use 101 access list for group A and 102 for group B, or customer B basically, and address IPv4 10.45.45.5 basically tells that this is my key server, right? So let's put this up on R5. That's done, right? The next is let's go and configure my group members, which is R1 and R3, right? Let's do that, and then the final configuration will be on my R2, right? So let's do R1 and R5, right? I think the configuration is going to be almost the same for R1 and R5, right? So let's pull that and let's do that. There you go. So for R1, we are again going to define my phase 1, right, which we did earlier, and also define my pre-shared key, which is 10.45.45. R1 is able to reach my key server, which we checked earlier, Now the GDOI configuration would be defining a group. We define a group. We need to use the same identity number we used on R5, which is 100 for customer A. Then we define the key server IP address over here. Crypto map, right? Define a crypto map and attach the group what you created over here to the crypto map, and define or basically attach the crypto map to the outgoing interface of R1, which is 0/0, right? That's done. Right, you can see the negotiation already starting. Let's do the same thing on R3 as well, right? Let's do the crypto part on R3. Yeah, so here is my R3. Pretty much the same. The phase one will remain the same. And in my GDOI configuration, I need to change from 100 to 200 because 200 identifies the VPN for customer B. And the rest is same. I mean, I define the crypto map and then go and apply the crypto map on the outgoing interface of R3, which is 0/0. Done. I think that looks good as well. Now the only configuration that is left is the configuration on R2, right? So what do we do on R2? So R2 has my VPN, right? So R2, my bad, R2 has my VRFs. So R2 will have a configuration which is kind of like a fusion of both my VRF aware configuration and my GDOI, right? Or basically the GetVPN configuration. So it's R2 is getting a mixture of everything. It needs to have VPN, it needs to have VRF, and also it needs to have GetVPN, right? So let's do the configuration for R2, right? Let's do it for customer A first, and then we can do it for customer B, right? It's very easy if you break down the configurations this way instead of doing everything in one shot, right? So let's do it for customer A. So we are on R2 now, and we are doing the GetVPN configuration for the customer A, right? Again, we define the phase one will remain the same, right? Remember in my VPN VRF aware VPNs, we define something called as key rings. Okay, you guys probably remember that keyring configuration. Yeah, so we have to do that over here because it has a VRF, right? Let me quickly check if that's right what I've done. Give me a sec. Yeah, perfect. That looks good. Yeah, so we are doing a keyring configuration. Why we are doing the keyring configuration is because if it was if this router did not have a VRF, then we would have simply done the pre-shared key configuration would have been just a line. We would have told crypto key, and then you define the key, and then you define the IP address of 10.45. But in this case, because it has a VRF routing table, right, the router will not be able to the VRF routing table doesn't have any knowledge about 10.45.45.5, right? It doesn't have any knowledge about that. So that's why what we do is we explicitly attach the VRF, which is customer A, right? So over here we attach the VRF over here using the keyring command, right? And then we define the pre-shared key, right? So these are the two extra steps, when you kind of have a VPN aware or VRF aware VPN. We do keyring and then we do ISACM profile as well, right? So without this, the phase one wouldn't work. We need to do this compulsory because using something like crypto ISACM key Cisco 123 address 10.45.45.5 would not work because we are talking about the VRF, and the address, this particular address is actually present in my global routing table, right? Okay, so yeah, so these are the couple of steps we do over here, followed by what we do is we go to GDOI. Now we do the GDOI configuration, because this part of the VRF is actually part of my group 100, right, which I've defined, so we put that as well. Next, what we do is we go and define the crypto map, right? We define the crypto map for that particular GDOI, and then we attach the group which we defined earlier over here. This group is attached here, and we also need to attach the ISACM profile as well, right, which we defined for customer A. We go back and put it on the interface, right? So that's done on R2. For the customer B on R2, we still have to do it. So I need not define my phase 1 again, because it's going to be the common thing for both. So I have skipped the phase 1, it is already put in earlier. I'm going to start with the keyring configuration and do the ISACM profile configuration, right, where you're explicitly you're doing this because it's a VRF kind of a setup, right? If it wasn't a VRF kind of a setup, if this router was a single standalone router, then we would have not done this. We would have directly done crypto we would have done crypto ISACM key and defined the key and the IP address directly, right? I've covered this in my earlier video, so you can go and check more on keyring and the ISACM profile, right, in the previous VRF-aware VPNs. Following that, we do the GDOI. Now the only difference would be that we need to define a different identity number, which is what we have defined on R5, which is 200. Maybe define different names for the groups, because we already have put ABC for group for the customer A, right? So we're going to use DEF over here. You create the GDOI group. Then the next step is crypto map. Crypto map, you attach your GDOI group here, and then also attach your ISACM profile which you defined here. And the last part is go and apply all this on the interface. Alright, so that basically completes the complete configuration of whatever we set to do, right? We have set up VRFs, we have GetVPN running on this VRFs, right? So what do? Let's do some testing, right? So to test, probably first what we'll do is, let's go down and see how our go back to probably R5 and see my key server, which will be show crypto GDOI members, right? So you can see the members. You have customer A, you have customer B. On customer A, I have two members, which is my router R1 and my VRF, which is in R2. For customer B also, I have my VRF in R2, and then I have my R3 router, right? So all my members are good. That looks good. Okay, now what we'll do is let's do some ping, right? So let's clear this router's console, right? So we are on R1 now. Let's see, do show crypto ISACM SA, right? So this is my tunnel for phase 1, right? So let's also see my phase 2, right? That's phase 2, and currently there are like no packets, which we will fix now by doing a ping, right? Let's do a ping to 10.2.2, which is my other end of the VRF, right? Other end of the network here. There you go, I did a ping. Let's see what has happened to my phase 2 tunnel. You can see that the packets which you pinged just now have been encrypted, right? You can see that over here, right? And that basically tells that whatever we have done, the GetVPN is working, right? So we did a ping from the 10.1.1 network to 10.2.2, and you see the packets getting encrypted, right? Yeah, so that's what I wanted to cover. What we did here was kind of like a fusion of everything, whatever we learned. It had a bit of VRFs, right? So first we set up VRFs over here on R2, right? We divided this router so that it is shared between two customers, and then what we did was we kind of created a completely routable network, which means every single router here, R1, R2, R3, everyone were able to reach R5. Once we did that, we created R5 as my key server because that's required for my GetVPN. And once you did the key server configuration, you went and did the configuration of the group members on R1 and R3. And then we also know that the VRFs which are in R2 are also members of this group. So we explicitly did the configuration for the VRF in R2. We kind of did the configuration such that it identified itself to be the group member of this particular VPN, and the other VRF on R2 also was configured to be part of this group VPN, right? And now finally we pinged the we pinged from R1 to R2, right? We pinged these two networks. We pinged this particular network, and we found that the packets are getting encrypted, which means our get VPN is working, right? Thanks for watching.